Okay, today is Sunday, 14th December 2025, 11 a.m, temperature 18 degrees centigrade, about 64 Fahrenheit, mainly cloudy, quite cool, but winter's not here yet. Temperatures are likely to rise next week up to maybe 25 degrees centigrade. Now, I may be wrong, and as usual, I'll emphasize I'm not a scientist or a MEDAKA expert, but I've come to the conclusion that some of my MEDAKA strains have been subject to an extinction vortex. Maybe extinction vortex sound a bit dramatic, but I think it describes what happened quite well. An extinction vortex is when a small population of a species is affected by adverse environmental factors, which then leads to a slow downward spiral in the population numbers, eventually ending in extinction. It's not a sudden extinction, but a slow decline in a small population over a period of time until it dies out. Now, a warning, this might be quite long-winded as I ramble on about this topic. But if you look at the definition of an extinction vortex, first of all, and keeping MEDAKA in pots like this, tubs like this, it's obviously a small population of that strain of MEDAKA. Also, when keeping MEDAKA outdoors, obviously varying environmental factors that can't be controlled, like temperature, rainfall, day length, etc. Some of which may be adverse for some strains of MEDAKA, either singly or as a combination of these factors. Now, as I think I've said several times before, you can't just generalize and say a MEDAKA is a MEDAKA is a MEDAKA, and they're all tough and can survive almost anything. You can't say that. I mean, some strains of MEDAKA can require surprisingly different environmental conditions to thrive as compared to what might be thought of as an average MEDAKA strain. So, looking at my MEDAKA strains, there are three here. There's Orochi, black. There's Miyuki, silver, platinum, whatever. And up here, for example, there's the orange strain. Now, all those three survive and thrive outdoors in my subtropical climate. However, I have here these three strains, what remains of them, which have been kept under the same conditions as in my subtropical climate as the thriving strains. Whereas each of these three strains here maybe had a population of, say, 15 fish. They've slowly gone into an extinction vortex, if you like. They've slowly declined until now there are only one or two left in each of the strains. So there's Nishiki, which is red and black, one female left. There's gold lame, one juvenile female left, at least I think it's female, and Yozakura, which is like orange head with lame, two surviving females. And that's it. That's all that's left out of the original populations I had of these three strains. And to explain this extinction vortex of these strains, I'll refer back to my previous video, which I called Hatching 100% Females, which I made about a week ago. There I explained that most strains of MEDAKA tend to produce more females than males if fry are kept at high water temperatures above about 30 degrees centigrade for the first 2 weeks immediately after hatching. Now, this is because at high water temperatures, a genetic male fry's body will, instead of producing the male hormone androgen, instead produces the female hormone estrogen when the fry is developing. And this results in the fry developing female sexual organs. And consequently, at these high temperatures, out of a batch of fry, you may get far more females than males at the very high water temperatures. At extremely high water temperatures, you probably get 100% females. And in my subtropical climate, there's a combination of the two environmental factors of day length and temperature, which results in the extinction vortex of these three Nishiki gold Yozakura strains of MEDAKA. Now, first considering my thriving orange Miyuki Orochi strains, I found that these three strains will produce eggs at relatively short day lengths. Now, it's usually suggested that you need a day length of 14 hours before MEDAKA will mate. But as I said before, not all MEDAKA are the same. Now, provided temperatures are reasonable, these three strains will mate at day lengths down to just below 11 hours, which is the shortest day of the year at my location. In fact, they produced a few eggs the other day. So this is the day length in my location, the shortest on the winter solstice is just below 11 hours, and these three strains will mate during that day length. So that means that these thriving three strains will produce eggs, quite a lot of eggs in, say, very early spring, when day length is 12 hours and temperatures never go above 25 degrees centigrade. Therefore, with fry developing at temperatures never above 25 degrees centigrade, these three strains will produce the usual. A batch of fry will produce, a batch of eggs will produce maybe the usual 50% females and 50% males most of the time. As it gets towards summer, when fry eggs are still being laid, but fries are being developing in temperatures much higher than 25 degrees centigrade, the strains may produce more females than males, but overall, if you add all the females and males produced over the whole spring, early summer season, there's still a very good ratio of females to males, and the populations thrive. However, for my three Nishiki gold Yozakura strains, which are now nearly extinct, I found that they usually will not mate until maybe early summer, when in my subtropical climate, day length gets to at least, say, 13 hours or more, and by then temperatures at times may exceed 30 degrees centigrade. Therefore, for the majority of the breeding season for these three strains, fry will develop in temperatures close to or greater than 30 degrees centigrade, and this tends to result in far more females than males. Not only that, but at temperatures, say, close to 30 degrees, the genetically male fry may not produce enough female hormone estrogen to change them to functioning females. The effect of the estrogen may be enough to make the male sterile. So maybe what physically look like males are not capable of breeding. And so over several breeding seasons, that will result in, if you like, a self-reinforcing downward spiral in the number of males, and consequently an overall decline in population until only a few females are left. That is an extinction vortex, and here we are. Each of these strains have only got one or two females left. So for strains like this, the way may be to avoid the extinction vortex, which happens in high temperatures in say a subtropical location, is to hatch the eggs indoors in air conditioning, which may be maintained at a temperature of about 25 degrees centigrade, and then keep the newly hatched fry at about this temperature for 2 weeks after hatching, so the sexual organs are fully developed, and then you get from a batch of eggs the usual sort of 50-50 split between females and males. You can then acclimate the fry to higher temperatures and move them outdoors where they will survive okay in summer temperatures. Now, I'll again emphasize this is in my particular subtropical climate, and my particular lineage of these 6 strains of MEDAKA. Now, it could be perhaps that all 6 of these MEDAKA strains would survive okay in a temperate climate, wouldn't be a problem. Or perhaps different lineage of these strains, like these 3 strains here, different lineage of these Nishiki, Gold Lame, and Yozakura. The different lineage might survive okay in my higher early summer temperatures outdoors. Who knows? But again, I'll emphasize, I'm not a scientist, I'm not a MEDAKA expert, so alternatively it may just be that these 3 strains here are becoming extinct because of my negligence, and I didn't look after them very well. But anyway, extinction vortex is an interesting theory to consider, and hopefully I don't come across that again with any of my other strains. Okay.